Hello everyone, welcome to my YouTube channel one more time again. Today I want to discuss with you the problems from the Pioneer round 2. This is day 1 plus day 2, problems A, B and C. So first start with the problem A, channel. Petya is an administrator of a channel in one of the messengers. A total of n people are subscribed to this channel, and Petya is not considered as a subscriber. Petya has published a new post on the channel. At the moment of the publication, there were 8 subscribers online. We assume that every subscriber always reads the post in the channel if they are online. So after this, Petya starts monitoring the number of subscribers online. He consequently receives Q notifications from the form a subscriber went online or offline. Petya doesn't know which exact subscriber goes online or offline, but he knows that whether it goes offline or online. It's guaranteed that such a sequence of notifications could have indeed been received. Petya wonders if all of his subscribers have read the new post. Help him by determining one of the following. So we have to find whether it's impossible to say they have read or not, or say it's exactly possible, or it's possible the subscriber have read, or exactly possible or exactly possible. That means it's guaranteed. So each test we have N, A and Q. N is number of subscribers, A is the subscribers online initially, and Q is the number of notifications. And after this, Q characters containing plus and minus. Plus means someone is online, and minus means someone went offline. So here, as you can see here, A and N and A. So at first, in this first case, we don't have to even look at the Q, because the number of subscribers that were online initially are 5. That means all of the subscribers were initially from the beginning, and so they don't have to go online and offline again. So we can just say yes. So now look at the case where it is impossible to tell whether they have read or not. So here, if someone who read the post goes offline and then he comes back, that means one person haven't read it at all. But if one person that read the post leaves and the one person that haven't read becomes online, that means everybody will read this post. So the answer is maybe. So here there are two main things that we need to consider. The first is number of pluses. So number of pluses without caring this minuses. If this number of pluses plus n is bigger than or equal to n, this is A, initial people who were online initially. If that is the case, then it is possible, but we don't know still it is guaranteed or not. So the thing we need to care of is the way we have that maximum value. For example, here we have, in the first case, we have the maximum value when we don't do anything, and here, so every time we get one plus, we are adding 1 to our to this maximum value x. So let mx be 0 and current be also be 0. Current value. So now, let me get this. So now current is 0. So every time we go through these queues, we will if this if it's plus. So what we have to do, current, we add 1 to current, else we subtract 1 to current. So, and every time maximum value would be maximum of the initial value and new current value. So after that, at the end, when we are using this, if this is true, if that's false, we can just return that answer is no. If that's true, we need to check this too, and maximum is here. So if a plus maximum, I mean mx, is at least n, then answer is yes. So it can not be bigger than this n, so we can just leave it like this, or this is also correct, because there is no case like that can become higher than n. So otherwise answer would be maybe, because it has potential to do it if we get lucky, but otherwise it's not possible. So here, look at this. So plus 1, plus 1, plus 2, plus 3, plus 4, but we need 5 people, and minus 1, so 3, 4, 5. Oh, we got 5 people, and answer is yes. So now we have to implement this solution. So first we need to get all the inputs. So long A, N, A, and Q. So we get all these values. Now notification, let's call it notes for short. And then rep is defined here if you are confused. So character P is here. Let's save them as 1 and minus 1 to make it simpler. So if P is plus notes I equals 1, otherwise notes I equals minus 1. So then we don't have to care about checking it is it plus or minus, so we can just add it. So now long log pluses equals 0, maximum equals 0, current equals 0. So now we will go through this notifications. If x is 1, then pluses plus. I mean we will increment the value of pluses. So current plus equal x. We don't care whether it's 1 or minus 1. We have to just update the value, and mx is the maximum of previous mx and current. So at the end, if mx plus a bigger than or equal to n, the answer is yes. If that's not the case, we will check this number of pluses using number of pluses, and if it's bigger than or equal to n, the answer is maybe. Maybe. Otherwise answer is no. So that's already. So answer is yes, no, maybe, yes. Yes, no, maybe, yes. Now we will submit the code. So submitting. Let's accept it. So we will move on to the problem B, split sort. You are given permutation P1, P2, Pn of integers 1 to n. You can change the current permutation by applying the following operations several, possibly 0 times. Choose some x. Create permutation by this. First writing down all elements less than x, then without changing order. Second, writing down all elements of P that are greater than or equal to x without changing the order. Replace P with newly created permutation. So read this part too. So you can pause this video to read this part if you don't know what the permutation is. So let us start this with clearing the previous one. So get this. So now here you can say that we have to, as you can see here, we can use this operations optimally and choose always the indexes that we can sort up to. For example, in this case we don't have to do anything, but in this case we can choose 2, for example, and less than 2 is 1. 1 goes 1 goes first and 2 goes second. So this will be sorted. Answer is 1. So in that case is we can choose 2 at first, otherwise we cannot get 1 to be in the first position, and then 2, and then 3, and then 4, and then 6, and so on. So overall we can use 4 operations. So now there is a pattern which you have to see here. For example, in this case, so 2 and 1. So here, as you can see, in the first iteration, the sorted parts starting from 0. At first we are looking for the current element that we are looking for. At first is 0, 1. So if we start from the 1, we need to go through the whole list, and then at the end we can get 1, and after that we don't have 2 in the later than 1. So answer, we add answer with 1. We add 1 because to get this 1 to be at the first position, we need to 1 operation, and then we go through the list again. So we are looking for 2 now. So 2 is at the end. So to get this 2 to be in the after 1, we need also 1 more operation. So now we are looking for 3. 3 is here. After 3 there is no 4. We can't get 5 till we don't have 4. So we can add 1 more, and now we are looking for 4. So we are looking for 4. We can get 4 right here. After the 4 we have 5, so we can get both of them to be after 3. So we add 1 here, and 6 is in the place. So as you can see here, all the operations we need is 4. So we can go through all the list like this. And to do this operation, the total time complexity would be O(n) square, because we have to every time 4 inside of the 4, and that is of course O(n) square. But with this time complexity, you will not pass the even simple case. You can pass this first test case, but you may not pass third or fourth. So we need to optimize it. So what we can do to optimize, we can use hash map hash function in C++, for example, unordered mob, or in Python dictionaries. So we are using C++, so let's use unordered mob map. So when we using unordered map, we can store this indexes of the every element so that we can look it up in the constant time if we're using unordered map. So let us get all these inputs. So we need long ones, n and p permutation first. Now we need unordered map. That's long and long. Call it dictionary, or you can call it hash map or anything you want to call. So we get pi, and then dictionary of pi would be, that is, we are adding values to this unordered map, and that would be the index of this element, and answer is at 0 at first, and current element is 1 that we are looking for, and current index that we are at is 0. So while current element is smaller than n or equal to n that we are looking for, and every time we current index would be 0 at first, and we add 1 to answers every time. So while current index is n, if dictionary of the current element that we are looking for is bigger than current index, or equal to, it can be equal also. So every time we update current index to be this this dictionary of the current element plus 1, and current element would increase by 1. If we cannot do this, I mean if it's smaller, then we break it. So at the end we have to print answer -1 and the new line. So the reason current index was this should be changed. So the reason why we are using -1 is that because when we are using while, we are considering this last one too. If we add last one, it would be 5, and we need to delete this one. Let's check with this test cases of the system. Submit. So it's accepted. So problem C, MEX Repetition. So this is also good problem. You are given array of pairwise distinct integers from 0 to n. Consider the following operation. The consecutively for each I from 1 to n in this order. Replace ai with max. Of this max here means that smallest non-negative integer x that is not part of array. So here is now this is some cyclic problems. There are some cyclic shifts that you need to be able to see. For example, here the one thing that we are not using is this 7. 7 is not part of it. So it is just moving like to the left, shifting to the right. So the answer is actually this part, and there is also unlimited supply of beginning and unlimited supply of ending, because this is cyclic shift. So answer at first was this part, this part. After doing some cyclic shifts, answer came to here, to this part. So the shifts we are doing is k divided by n plus 1. So, and all we need to do is implement the solution. So first long n and k is, we need to get this inputs. After this we create one vector for an. So I 0 and ai. Then we use unordered set to find which is. For example, in this case we didn't know what the number is that is not participating at all. We need to find 7. So to find 7 we can we can check every time from 1 to 0 to the n, and check if it's part of this array or not. But if we do this with a vector, it would cause some time complexity problems and could lead to time limits. So that's why we are using a set, and specifically an ordered set. So we call it helper for every element. We insert the element here, and then let's call this element we are looking for max due to the name of the problem. From 0 to the n plus 1, we will check if helper count I is 0, max is I. Then we break it, the loop. So now we need also one more vector, call it b a. So the first value in it should be, as you can see here, it should be 7, so that we can use it later. But when it comes to the elements, that should be with this unlimited supply at the end, we can just use this modulo by n plus 1, and we don't have to worry about this things that we need to have at the end. So we will insert this in the first position. So, and end of our loop would be k. If it's bigger than n plus 1, we need modulo, because we don't want to do it over and over again. If it becomes 0, we will increase it to n plus 1. So now for every element from I that starts with 2 times n plus 1 plus 2, 2 times n plus 2 comes from this as I said before, this unlimited end. I mean this part is n all itself, and this part has length n, and if we add one max, it would be n plus 1. Due to this things that we need at the end, we will multiply it by 2, and this becomes 2 and n times 2 plus 2, and from these we subtract n and minus n, and we go through till we have 2n plus 2 minus n, and we will increase I. So we will print b. As I said before, we need to print modulo n plus 1, and there's some space, and at the end we will see output new line. So let's get this values and put in the input. So our std out should be same. Yeah, it's same. So now we will check here. So follow my YouTube channel for more content like this, and also I'm preparing one video that is going to help some people who are stuck at newbie for a really long time and want to increase your pupil. So that's why it should be better if you follow it. So goodbye, that's it for today.